Our brains are composed of neurons, which form links called synapses. Synapses communicate using neurotransmitters, and all that we experience in our life is sensed through these. All of our senses, touch, smell, taste, even audition, is thanks to neurons. This information reaches other neurons and do this at an immensely fast speed called the speed of thought. Electrodes create electric fields around our brains and detect the synapses in our brain, relaying it to a machine to have a better idea of our thought process. Our brain is composed of two areas, the limbic system and the cerebral cortex. Our cortex is why our consciousness exists, and Neuralink wants to create another area in our brain. They plan to increase the number of neurons to remember things or reach parts of our brains that aren't active yet. This might seem a bit weird or something out of a science fiction film, but the truth is that it has amazing potential to benefit people with severe neurological issues or those who are paralyzed. On top of that, neurons do not reproduce like many other types of cells, as they're unable to perform mitosis. They can't regenerate, and that's why they're so important. Yet after we turn 25 years old, they start dying at an alarming rate, eventually causing our brains to age until we die. Sounds terrifying, though there's hope thanks to Neuralink, founded by Elon Musk. Neuralink is a private neurotechnology company that began developing implantable brain-machine interfaces known as BMIs. Those are the machines that we're talking about at the beginning that create a direct communication pathway between an enhanced or wired brain and an external device. However, many people wonder why this is necessary and how it's even possible. It's not exactly a technological issue, as Neuralink is currently developing the exact technology to help them achieve this purpose. It's actually a bandwidth, speed, and connection problem. It depends on how fast we can process this information into our brains. However, to do things, our human brain is limited in its ability. The speed of thought, as fast as it is limited on how fast it can do things and how fast we can process what we do. Imagine typing things on a computer. You can type as fast as you want, let's say 60 words per minute, which is well above average. And still, you'll be limited by that at the speed at which your neurons communicate with their synapses. Elon Musk has claimed several times that he aims to build a scalable implant that's going to connect human brains with computers by using Neuralink. He's already implanted these chips into rats and plans to test its brain-machine interface within 2 years, including a long-term goal of people merging with artificial intelligence. Instead, Neuralink wants to do something revolutionary. They want to cut the middleman between these processes and boosting your brain's bandwidth and speed to records never seen before. It's going to boost the speed with which we do things to the point never seen before in human history. So what are the pros and cons of this happening to our brains and bodies? Well, there's actually a few things wrong with it. Neuralink has developed a custom chip that is better able to read, clean up, and amplify signals from the brain. Right now, it can only transmit data via wired connection. It uses USB-C, but ultimately the goal is to create a system that can work wirelessly. That wireless goal will be embodied in a product Neuralink calls the N1 sensor, designed to be embedded inside a human body and transmit its data wirelessly. It may read fewer neurons than the current USB-based prototype. The N1 chip is made to communicate with other devices wirelessly and is capable of reading and writing information. The N1 sensor will be controllable through a mobile application, Bluetooth mouse, and Bluetooth keyboard for helping patients learn how to use the chip effectively after implantation while they're at home. These chips are installed into your brain using threads, and they contain 32 electrodes. They're extremely small, being 10 times smaller than a human hair. However, the N1 chip procedure is not like putting an implant in your head designed to manage epileptic seizures or a pacemaker in your heart. This would be elective surgery on presumably healthy people for non-medical purposes. Right there, we're in a completely different ballpark, both legally and ethically. On top of that, since Neuralink is a communication system, there's also the issue of both regulation and control. Who's going to make sure things are kept in check regarding the privacy of those using Neuralink? Imagine a scenario with an endless number of governments, advertisers, insurers, and marketing folks looking to tap into the very biological core of our cognition to use it as a means of selling you stuff. There are many ethical, technical, and technological hurdles that haven't been solved yet due to it. There's also the thing with security. What if the chip gets hacked? Once you connect something to something else, who's to say a smarter individual can't just develop a way to hack into the chips and damage somebody with potentially life-threatening results? What it really comes down to is this: Across a number of fields at the intersection of law, philosophy, technology, and society, we're going to need answers to questions no one has yet thought of asking. On top of that, Musk has now fired the starting gun for competitors, and as Urban observes, an eventual neural revolution will disrupt almost every industry. It would be a game changer in the world of business, and one that probably many leading players will want to partake in. That's also not taking into account the fact that algorithms and servers dealing with the requests your brain user interface makes will be centralized and run by and for the people who develop artificial intelligence. The artificial intelligence we gain access to with this technology will not be run in our interest, but instead to maximize the same desirable outcomes that these data centers and search engines are run for today. You might gain access to advanced cognitive abilities, but you can be prepared to bet that all your cognition will be monitored by centralized databases and will be removed the moment you criticize the products, don't keep up with your subscription, or go against the company's wishes. At the same time, a successful implantation of the chips could mean a great way for paralyzed people to partake in their daily activities. The first big advance is flexible threads, which are less likely to damage the brain than the materials currently used in brain-machine interfaces. The system could include as many as 3,072 electrodes per array distributed across 96 threads. Let's just take a moment to let that sink in and compare it to the current standard in which Parkinson's patients are only allowed a maximum of 10 electrodes at a time. Using this revolutionary technology for science purposes will prove to be a big step towards the evolution of humanity. Right now, Neuralink is testing its chips with rats in order to make sure that their platform is stable. However, if it works, then it will solve the crucial brain bandwidth problem via robot surgery. The connection made using thin, flexible threads would allow many neurons' activity to be recorded. The hope is for better, more precise outcomes than previous attempts at brain-machine interfaces. Neuralink mentioned in their July 17, 2019 presentation that a monkey implanted with their device was able to control a computer with its brain, as well as decoding movement intentions in the motor cortex, which could allow a paralyzed person to control avatars or assisted robotic devices. Neuralink also stated that their technology could be used to decode speech intentions, which also originate in the motor cortex. In the future, scientists from Neuralink hope to use a laser beam to get through the skull rather than drilling holes. Elon Musk and his team have confirmed that achieving such technology would take quite a long time and even more research, but this one's coming. Neuralink's eventual goal is to be able to achieve a symbiosis between artificial intelligence and people's brains. The first person with spinal cord paralysis to receive a brain implant that allowed him to control a computer cursor was Matthew Nagel. In 2006, Nagel played Pong using only his mind. The basic movement for this action took him only 4 days to completely learn. Since then, paralyzed people with brain implants have also manipulated objects with their minds and moved robotic arms in labs as part of lab research. There's always new technology coming up to change our lives, but Neuralink represents the advent of one of the biggest changing events that will change humankind. There are many positive things that could come with this change, and there are many negative things that could happen too. Only time will tell if the positives will outweigh the negatives, or what would happen in such a case.